Hello. It's sometimes implied that the Betamax format was sold in small numbers and exclusively by Sony. This is of course complete twaddle. The biggest selling video recorder in the UK in 1983 was the Sanyo Beta VTC5000, which outsold all VHS models. And it was followed by another bestseller in the VTC5150, then also a range of front-loading Beta machines. Sanyo machines earned a reputation for excellent reliability and ease of maintenance. So there's large numbers of Sanyo Beta machines still in existence today. We're going to work on the VTC5150 and refer to other models as we go along, covering many of the issues you're likely to come across. Also see links below for my webpage on servicing these machines. So here we have a VTC5150. Now briefly I'll show you the difference between the earlier VTC5000 and the later 5150 model. Both sold in huge quantities. They were assembled in Wales. Apart from a cosmetic improvement on the 5150, you've got reverse play. You can play backwards reasonably well, and it's something that you could do on a two-head Beta machine that wasn't possible on VHS. But there's a much more important improvement on the 5150, and that is that freeze frame and picture search are in colour on the 5150 and only in black and white on the 5000. So the 5150 is the one to get if you can get one. Now this particular machine is in working order. You can see that the clock is working. If there's no clock or if it's shimmering, that can be indicative of power supply problems, and we'll look at the power supply later. So let's just fire this one up and we'll see what sort of results we get. You can hear it squealing, and there's a lot of dropouts on this tape. That seems to be too many to me, so there may be a problem there, and we'll freeze frame it and you get some kind of freeze frame. Here's a little trick I always found about the 5150 when I had one. If your freeze frame is not very good, you've got a noise bar in it, you can shunt it away by hitting the reverse play a couple of times, and it can move the noise bar off the screen. In this case it's not there anyway. So okay, it's working, but there are a lot of dropouts. Maybe the heads need cleaning. They don't appear to be overworn. The tape itself obviously is struggling. And we heard that squeal when we first started, and there's a clue there's a problem. That horrendous noise during unlace is completely normal. They do that from new. Now this machine has also had installed already a new idler and belt kit. I did that some years ago, but I'll do it again just for the purposes of showing you how to change the idlers and belts on these, because you have to do them pretty much every time you get one of these in. This machine's already been taken apart and some of the screws are missing. There's supposed to be 3 screws along the back here. But before we go there, we will power it down on my isolation transformer. There's a strip here which is normally stuck down better than this. Take this strip off, and normally, say, these sticky pads here will hold that down, and you can replace those with some kind of double-sided sticky tape. And 2 screws there, we'll pop those off. Now, as I'm going to be working on this machine, what I tend to do is switch off any monitor that's connected to it, and there's a good reason for that. A lot of, especially this kind of vintage of TV, the power supply has a capacitor straddling the mains input voltage and the DC side. It's a capacitor which is designed to stop, I believe, the output side of the power supply is starting to drift up in terms of high voltage, but the risk is that they do tend to feed back through the connectors something like half mains potential at very low current. But if you're not expecting it and you're connected to something that's not earthed, you can get yourself a small shock. Once upon a time I was up a satellite dish in the pouring rain, and the satellite receiver was plugged into a TV which is in standby, and I got a shock up on the top of the ladder, and I wasn't impressed. So take that off. Oh yes, look, Betacord. So you know, people think of the format as called Betamax. Actually, the domestic format, is called Beta, and Sony called it Betamax. Sanyo called it Betacord. I've got some Toshiba machines outside. I'll look up and find out what they called it. The professional version was called Betacam and used the same size tapes, or at least could have been the same size tapes. The format's really called Beta. Let's eject. Take this lid off. Okay. So, to get good access to the deck, you need to eject. Now, there's a train of thought that says, a school of thought that says, you need to take the cassette carriage off in order to work on the rear idler. I never do, unless there's some special reason I need to get in there. There's some other problem. I wouldn't take the cassette carriage off, but if you need to, it's not unbearably hard. I forget which of the screws. Oh, there we are. Screws there and at the back, and then on the other side as well. So yes, if you feel the need. Here's the real idler. Now, I'm not sure how much of that you can see. It's a little hard to get that on camera because this stuff is in the way, but hopefully you can see. There's a real idler there, and that swings from side to side depending if it's doing rewind, fast forward or play. And this has a gear at the top that engages with the real tables here. It should be noted that later models such as VTC50, VTC10, the VTC100, which are front loading, have a different rear idler, and instead of being geared, it's got a tyre on the top idler, and that was probably done for lower noise, but actually they don't last so well. They tend to wear out a bit. And there was one front loading model, which did share more or less the same mechanism as this, VTC5150, I believe that one was. So the later front loading models have the one with the tyre on the top, and they're not interchangeable. Otherwise the mechanism is very similar. It has to be said, Sanyo engineered this deck to an unbelievably high standard. You know, people sometimes think of Sanyo as a cheap manufacturer. Well, the build quality on these machines was just ridiculously high. They are so well made. I have never had, hardly ever had, a mechanical failure of the loading mechanism, the lacing mechanism on these. You know, they're brilliant. So all we have to deal with usually is the idlers and belts. Now, Sony, on some of their machines, they dispensed with this idler and belt malarkey and had a rather nice system which didn't involve any drive belts, and the real idler dispensed with the friction drive and had a magnetic coupling to do the swinging of the idler, or they called it pendulum, from side to side, and that should have been incredibly reliable, and it would have been, but for the fact they made a bit of a mistake with the way it mounted on the deck, and it would wear its way through the deck. Terrible shame. They almost got it to perfection. Now then, I'm going to show you. Here I have some of these idlers. This is a brand new spare idler, and it comes on this complete metal housing, so you could in theory drop this entire system in. I'm not sure if that metal housing is actually correct for this model. It looks like it is actually, but you don't want to go there. It's an enormous amount of work to release all that mechanism. You have to take the real tables off. It's never worth it. What we're going to do is take this assembly off here, I'm afraid, throw that away and install it on top of, replace this one and install it in there. So now I know this one's in perfect working order, but I'm going to show you how to do it anyway, as best I can, bearing in mind it's a little bit buried in here, it's a little bit fiddly. Now, one of the things is there are some washers inside here. Tell you what, I'll take this out, wrapper. This is new old stock Sanyo stuff. There are some small washers inside the idler assembly, and you don't want to lose those. Also, there's a black circlip on the top. These came with two different variants of the circlip. There's this kind of split washer type, and then there's a proper, what you call sort of traditional circlip, and this is the later type, I believe. Now, so when you come to the machine, it could have either the metal circlip or the black split washer type. Just don't lose it. So they're interchangeable. So what we're going to need is a very small screwdriver to push that circlip off. But I think I'm going to have to get you in a bit closer to see what I'm doing here. Okay, so here we have the real idler. This is the circlip. Hope you can see that. And this is the real drive belt. Again, I do hope you can see that. This is the real motor. So the first thing I'm going to do is release this circlip. Now, like I say, very often you come to one of these, you'll still have the original metal circlip on the top. In this case, I already have the split washer type. And it's a little fiddly to remove whichever type you have. But you need to try to sort of hold one side and pry the other side off with a screwdriver without it pinging itself across the room. If you do lose one, well, you do get a new one in the replacement kit, so you may get away with it. There we go. So that's the top circlip. In theory, you should replace it with a brand new one if you remove it, but of course you can't do that, can you? Because you're going to have to take one off this assembly first. So where are you going to get a brand new one? Right, let's put that to one side. And we can now take the top part of the idler off. Okay. There's the top part of the idler. And this sits on top of one washer, which is now there. So we need to take that washer off and not lose it. Now, here we have the drive belt, which, if it's still in place and you've still got the original belt, it'll either have snapped or it'll be all misshapen and sloppy and not working. So typically you wouldn't find a belt in such good condition as that. That one, okay, it's gone out of shape slightly because it's been sat on this deck for a few years, but actually it's basically a brand new belt. And now we have the rest of the idler, and that can all be pulled off in one piece, or it doesn't matter if you take it off in two pieces. You take it off and it splits in half, it doesn't matter. And I'll show you what that means in a moment. So I'm taking the whole thing off. But if when you were taking it off it's split there, it doesn't matter, just don't lose that washer there. So clearly what I would now do is release all these parts from this lower mechanism and transfer them over there. In this particular case, this idler assembly is brand new, it's never been run, so I'm not going to do that. However, since my drive belt seems to have gone slightly out of shape, I think I will replace that one. So refitting, if you do fit this in two parts, if you do fit that part first, and you've got that washer, this time it's stuck to there, of course you'll need to release this. You need to pull this idler back before you can put that one on the top. So we refit that. If you have to change the reel motor, now's the time to do it. If your reel motor is shot, then take the idler off first, and you can get to the screws here. The screws are there. There's one there and one there, and you'll need to take the bottom of the machine off. Symptoms of a bad reel idler include, surprisingly, a bad picture. If you hit freeze frame and you get white streaks that look like dropouts on the picture, but they keep moving, they don't stay in the same bad bit of tape, but they keep rolling through the picture all the time, what's going on is the motor is arcing. So then you'll have to replace the motor, and that's a little hard. You probably have to get one off a scrap deck. Right, so at this point we need to fit the reel belt. Now I have these belts kits that came from a company. I'm not sure if they're still in business anymore, Grandata. I bought a bunch of these back in the day, and this belt kit comes with 4 belts, which is a little odd because these machines have only got 2 belts in them. And what we have here is the smallest one, I believe. Yes, it's the smallest one is the reel belt. Then I think the second smallest is the loading belt, and we'll check that in a minute. And then the other 2 are for the 2 variants of front loading mechanism, the type fitted on the later M and N models like the VTC5000 and the type fitted on the VTC5150, which is a slightly different loading mechanism. So in this case we won't be using these 2 belts, but I tell you what, don't throw them away. At least one of those is a perfect fit for the cassette carriage belt used in a Sony U-matic VO9800P and similar models, and I have a video on that. I'll show you a card on a minute, and you'll see me actually installing one of those belts. Right, so here we're going to fit the reel belt in here. Actually, it could be handy if you have some tweezers to do this. Let me grab some tweezers to pop that belt in there. I have on occasion seen a machine with an elastic band or an O-ring in this position, for heaven's sake. When you've got it on, rotate it a few times, make sure the belt is straight, doesn't have any kinks in it. There we go, that belt's nice now. So that's installed. Now we can fit this on the top, but we do not want to miss out that washer that we had earlier. And if you drop it in the deck like that, then that's slightly frustrating. You may have seen a video I did recently on a Hitachi i8 deck where I kept dropping screws into the machine, and that was quite annoying too. I suspect my tweezers aren't meeting very well. So we won't use the tweezers for holding that shim. There we go. Washer, shim, you tell me, what's it called? Right, that's finally in position. Top idler. And now refit this tiny split type circlip. Lovely. I've just switched the machine on. It does that little shuffle where it pulls that reel. You should have really good fast forward and rewind there. Great. Now we're going to change the loading belt, which is at the back of the deck, so I'll just adjust you slightly. Now then, on occasion people have been a little bit terrified by this label. Caution, do not remove center nut. It's not talking about this, it's talking about on the head drum. You can quite safely remove this screening cover. While we're here, I'd like to show you something about how the mechanism works. Sanyo, their approach to Beta was somewhat different to Sony, and one of the things is that the head is what they call a head disc. It's a tiny little disc, sits in this slot. I don't know if you can see the head tip is just protruding here, and the upper drum is stationary. On most VHS decks, the upper drum and the head tips are all one assembly, and they all spin together. This way of doing it, well, there were a couple of reasons. You could argue that the heads were inherently self-cleaning because they didn't go round on the drum, so they had more opportunity for oxide to shed off than if they're sat in the drum where the oxide would go round with the head. So there's a case for that. Now, before we change the loading belt, we can fix a problem here. Do you remember when we started we heard a squealing when it started to play the tape? Well, what's going on there is these guides which go round on the loading ring become a little bit contaminated, and the tape was squealing as it was going past them. And what we're going to do is just show you what happens when you lace up a tape on these. So we have a loading ring. U-matic works the same way, and these guides here are static guides, they're the stationary guides, they don't rotate in any way, and if they get oxide on them, then the tape can squeal as it goes over them. So we're going to clean all those static guides. It's an incredibly reliable loading mechanism. I should say that that is not unique to Beta. You could pull that off on VHS if you wanted to, and Philips did. They had a range of mechanisms called Charlie decks because they laced in a C for Charlie, and unlike Sanyo, the reliability was atrocious. So these are ridiculously reliable, but Philips managed to completely bodge it up and came up with something that was unreliable. Now then, I've just got a cotton bud with isopropyl alcohol, IPA as you'll often hear me call it, and we're going to go through all these fixed guides here and clean them, and you will be amazed how much difference that makes. So I've often had it on, well, it can happen on any Sanyo model with this basic mechanism, but strangely enough I've found that the VTC series machines, like the VTC100 in particular, is particularly prone to this problem. I don't know why it'd be any different on that one. But you need to clean these guides up. Now you wouldn't want to use a cotton bud like this on the head tips. That would be asking for trouble. You won't need to use proper head cleaning sticks. But for static guides like this, they're absolutely ideal. And while it's in pieces, you would clean the audio and control heads, wouldn't you? So the audio control heads, one of the few things I dislike about Beta is the position of the audio control heads. They're a bit hard to get to. They're back here facing outwards. There we go. One thing that might be said to be better about VHS is that the head's a little bit easy to get to, and some machines, some of the Panasonic machines I use, I clean the audio control heads without even taking the machine apart. I can clean them from inside the front flap, which is just marvellous. This is the erase head, and though I'm not going to be doing any recordings and you say, why am I bothering to clean the erase head? I'll tell you why. It's part of the tape path, and so the tape is going past it, and if you have gunge on there and it's sticky, then it's not going to do the tape path any good. It could potentially cause the tape to stick and squeal. Right, so what we want to do now while we're here is clean the heads, both the head tips and the drum. So for that we're going to use proper head cleaning sticks. I have one here. Okay, this is not actually brand spanking new, but we have some head cleaning sticks here. These are rather hard to get now, so a drop of IPA on that. Oops, I just poured IPA down there, which was unintentional. So I'm going to very gently just rest that on the drum and rotate the head disc past it. Great care. You do this wrong, you snag the heads, and you've finished your machine. Right. Do that a few times. Sometimes, if they're really bad, you get a streak on the head cleaning stick, and then you know you've cleaned a problem. Now, keeping the heads away from the drum, I'm going to go around here. You can see this ridge. Hopefully, you can see this ridge in the lower drum, and that is the part of the guide for the tape path. And it's important that all the metal above that is clean and shiny, and it goes round the back here, which is a little hard to get to. If that's contaminated, you will get issues with tape not running cleanly, potentially picture quality issues if it's pushing the tape away from the drum. So we clean that up, and this might help the picture quality slightly. Right, and I'm going to clean the upper drum as well, just a bit. The tape sits under these plastic guides here, so anywhere under there is worth cleaning, making sure that I don't catch the heads. Obviously you can get head cleaner tapes, but they won't do as thorough a job as this. Beta, domestic Beta head cleaner tapes, if you can't get them, you can, at a push, use studio Betacam head cleaner tapes, because Betamax and, if you like, domestic Beta and studio Betacam are the same size. Right, that's a little better. Now we're going to change this loading belt here. Not the easiest thing in the world to get to. Well, compared to some machines, I suppose it's not bad. There's a tendency to get your belt covered in grease from the mechanism here. Now again, this belt is essentially new, but it's been sat here for a while, so I'll replace it anyway. So that one's not got any mileage on it, but it's been sat there for such a long time, it's gone slightly out of shape, so we'll replace it. Ah! Okay, which belt is it of my collection? That's the old one. It's the... pretty sure it's that one, isn't it? Pretty sure it's going to be that one. I think that one is too big. This is a little fiddly because you need to try to get it onto the belt underneath, the motor underneath. You could do this if you've got the bottom off the machine. It might be slightly easier because you can get to both sides at the same time then. We'll get there. Good. That's nice. We'll just test the machine. That's very good. Something else I should point out here is this is the dew sensor. These are fitted to many video recorders, if not all video recorders, and the way they work is a bit counterintuitive. Normally when something gets wet the resistance would go down, but actually the resistance goes up. And what's going on here, it's mounted on top of the head, so that if you were to carry this machine from somewhere very cold into a warm room, say, you would get condensation on the head drum, and you don't want that. If the tape is pulled around a damp head, it can catch on the head and snatch. So all machines pretty much have got this dew sensor. If you were to change the heads on one of these machines, I have to say it's not quite the easiest job in the world, but you have to remove a lot of these screws and take this top drum off, the static drum, and then the head disc is inside. And you've got to desolder 4 wires, make sure you remember which ones go where. It's not impossible. I have changed heads on VTC5150 or similar before. Head wear actually is fairly unusual on these machines because they unlace, like most VHS machines did at this era. Head wear is pretty low. The exception being the VTC5000 Beta Hi-Fi, which has a different head disc arrangement. It's kind of a cross between VHS and Beta. I firmly believe that the heads on the VTC5000 weren't built by Sanyo. I suspect they were built by Sony, and they seem to be made of paper mache, and it's the only Sanyo Beta model where the heads wear really badly. Right, let's reassemble this. Something else I want to show you while we're here. There's a bunch of preset controls here, and it's quite common to find that the preset tracking control is slightly off position. Now there's a tracking control on the front, I'm trying to point to it here, and it has a center ident notch, and very often you'll find that tapes don't play back with that in the notch position. You have to have them all to one side, and you have to adjust one of these controls. Shall I find out which one it is? Let's do that, shall we? We'll power up my monitor, we'll play the tape, so on this particular tape tracking it's good actually when it's in the middle, but which tape is it? Is it that one? I think it's that one. Let's adjust that. Right, that's it, that's the one. So now the tracking's gone off from my recording, and you have to put the tracking control not in the center. So there we go. That's the control you want in order to center the tracking. I've changed tape here. This is a Sony Pro X tape. Other ones I'd recommend are TDK or Kodak, or some of the realistic ones from Tandy, where you get windows on both sides, and that's helpful because a lot of beta tapes have only got a window on the supply spool. Now, if the take-up spool is not keeping up with the tape as it comes off the pinch roller, then you can finish up with tape slack here and either tape damage or the machine will shut down. The reason for that can be due to a component which ideally should be changed here on the SY1 servo board. As the real motor gets a little bit tired, older, a couple of component changes on here help with both take-up torque and also the amount of torque that's applied to the spools during the unlace. So let's just watch those through a moment. So you need to make sure that this is rotating smoothly during play and doesn't keep stopping and trying to catch up with itself. And when you press stop, it unlaces here and it needs to keep up with pulling the tape back onto the spools. So we'll watch that happen. When you see them both do that at the end, it's good. But if that isn't happening, it doesn't necessarily mean there's an actual mechanical problem. It can be a component change on here, the SY1 board. So let's investigate that. Switching that off. There's a resistor here and a Zener diode down the bottom of the board. Now, there's two versions of this board and the components are laid out in different places on them. This seems to be the most common type. So what we're going to do is, what we typically do is change this resistor. I think that starts out as 2.2 ohms, and I believe it's a fusible resistor. And I have actually bought in and have sold some of these along with the idler kits. Some 1 ohm, I think it's half watt fusible resistors, and the diode is changed to a 3.3 volt Zener. I forget what the original voltage was, but it's on the circuit diagram, and that's the one that does the play torque. So the diode down the bottom is for play torque and the resistor at the top is for the unlaced torque. So to do that you need to get this board out, and though this panel has already had those components changed, I'll show you where they are and I'll show you some of the pitfalls. Firstly, of course, you need to switch the machine off, extremely important. So you think this is going to be easy because the board is just here, and how hard can it be? Well, harder than you might imagine. So we take out the screw at the back here of the PCB holder. And then there's an edge connector at the front. I'll get that into the picture. There's an edge connector along the front here going down to meet this front circuit board. So all you need to do is ease it off the edge connector, and now you don't even need to undo any of the wiring on the top. So you can get to the diode and the resistor. So the resistor is here underneath the heatsink, and I put these heat resistant sleeves back on that came from the original one. The resistor is part number R49 or R3049, and the diode is D3006 or D6, and is on the, in this case, lower part of the board. When you're changing a diode, of course, you need to make sure you fit it the right way round. So let me just find where that diode is and point it out to you. One moment. D6. There. There it is. D6. So you can change that Zener diode. I'm not sure this one has been changed actually. That looks like the original one. So in that case, shall we go ahead and change that? Preemptive strike? We'll change that. So there it is, D6 there. And the cathode is pointing that way. Okay, there's the original diode. Okay, that diode is marked 2.7, so I'm suspecting that's a 2.7 volts in a diode, and the one we're going to fit is, I believe, 3.3 volts. Yes, 3.3 volts, and we're going to mount it the same way around, aren't we? And always do with diodes is another double check to make sure it's the right way round, which it is. Okay, and then this resistor here, which in the original diagram was 2.2 ohms, I think it was. Yes, we're changing it to 1 ohm, but that's already been done, so we're not going to do that one. But clearly it's the same procedure. So, you say, what could possibly be hard about that? That's a complete walk in the park. Anyone with a soldering iron can do that in 10 minutes. The next job is putting the circuit board back again, which means plugging this back into the set of pins which is on the front panel. That sometimes is a struggle, but before we do that, we're going to check the solder points here, because I've seen this suffer from dry joints on this connector and also on the front panel. So let's go through that with a magnifier. Oh yes, yes. There's no way I'm going to be able to show you that without a microscope, but one of the pins, the classic dry joint on there. So we're going to resolder that. You can get some very odd symptoms if they're not in good order. The machine can act very strangely. You can get symptoms such as no clock or ignoring certain functions. So we're going to go through the whole thing with some old-fashioned leaded solder. So it's the second pin on this one, which is dry jointed. Now the solder is a bit generous on some of these pads, so there's every opportunity to finish up with a solder bridge. So you really need to be quite careful. Definitely worth going over this with some kind of microscope to check for solder bridges. And I have a little 10 times handheld here. Right, I'm happy that that's in good working order. Now we have to try to refit this, and it's easy to get it misaligned. You need to get it sat all the way down and lined up. There's a good case for taking the front panel off. Let me see if I can do it without taking the front panel off. Yes, I think we have done that. Actually, I will look at the front later. But now we can refit the PCB stand at the back here. Let's test the machine before we carry on. Fast forward, rewind, play, and it's working fine. Pause, picture search. Next we're going to have a look at how to get to the underside of the machine, and we'll also take the front panel off, which you wouldn't normally need to do, but we'll do it for completeness today. So there's a set of screws on the underside. Let's get those off. Sanyo have been very thoughtful in that the screws to take the front panel off here are here, 1, 2, 3, and they've left gaps in the under panel so that you can get to them without taking the bottom off. I mean, that's just the sort of attention to detail that Sanyo applied to these things. They really are brilliant. In this particular case, we're taking the front panel, the bottom off anyway. Okay, so here we have the lower PCB. Got a few cobwebs in this one. So we'll take off the screws which have got the red markings on them. Just before I move away from this panel, I will mention that some time ago I had a Sanyo machine, one of these, which had intermittent colour, and it was due to a dry joint on this bottom panel. So it's worth just giving it once over, looking for dry joints. Right. Panel nicely moves out the way, and you can get to the underside of the deck. So here we are. Here's the loading motor. If you wanted to make your life a little bit easier when changing the loading motor belt, you can do that. Here's the capstan motor, head drum motor, reel motor, loading motor. So it's a 4-motor design. Let's have a look at the front panel. Now, as I mentioned earlier, you don't need to take the bottom off in order to access the front panel, because these screw holes can be got at. But let's go ahead. What we do need to do before removing the front panel is carefully take off the tracking control. If you forget to take that off, it'll ping off somewhere and then you'll lose it. Right, in this particular case, I'm going to put the screws back in this bottom panel because I don't want the board swinging around when I'm working on the front. So I'll just do that and we'll come back in a moment. So I've undone the 3 screws underneath. I've taken the tracking control off. I'm going to undo 3 screws at the top. And hit my light with the screwdriver. And there's an earth wire here. Unplug that. Now, something I'll tell you is if you find that the display is dim, very often it's because this filter here has become contaminated, especially if I think somebody smoked in the room. So it's worth giving that a clean, and you might find the display is brighter and sharper as a result of a quick clean there. And we'll very carefully clean the vacuum fluorescent display itself. Now, there's something about this front panel. Well, several things. I wanted to show you the other end of this connector here. This is the part that the servo board plugs into, and that also can suffer from dry joints. So if you're getting generally weird behaviour, it may be worth getting this panel off and looking at that. And we're going to have a look at it anyway, just for purposes of completeness. These clips at the top, and of course in taking this off we are unplugging it from the servo board. Right. So here's the edge connector. The contacts go round and solder onto this side, and it's worth checking for dry joints along there. So I'm going to do that with a suitable magnifier now. And I would say they all look excellent. No dry joints on this one, but I have seen them. Okay, let me show you one other little thing here. If the mood takes you, this has an option, has a couple of options. One is 3-day and 8-day. Why would you want to change the timer from being 3-day capable to 8-day capable to 3-day capable? Bear in mind the timer can't do multi-event timing recordings anyway, because the tuner only had one position. Of course, it's all a bit irrelevant today because you can't record anything terrestrially anyway. But this thing might suit you. There's a slot here that says 12 hour, so as it stands, the display is, it says AM. That M is for memory on the counter, and PM, but the AM and PM indicators never operate. Let's power it up and you can see. If we select clock set, I'm going to keep my fingers away from this because it's high voltages, you can set hours and minutes, but the hours just spin round to 24, 0. So if you fitted a diode in that 12 hour position, it would operate the AM and PM indicators. Shall we do it just for fun? Yeah, come on then, let's do that. So as this D5 slot here, we can pop a diode in there. 1N4148 or similar. Of course we need to put the diode with the cathode facing the way round that it shows you on the diagram. Okay, so we have diode soldered into D5 position. Let's see what happens to the clock now. It says 12 AM. Right, so we should, if I cover that, we see it a little clearer. So we've converted that, which is just a bit of fun. Let's reassemble this front panel. Check everything's still working. Good. Okay, let's reassemble the front. One thing to remember, of course, is to put back this earthing contact. If the machine's been mistreated in the past, sometimes these buttons can be snapped off. You may have to do a bit of plastic welding or gluing to try to get them back into position. It can be very hard to fully repair those. Right, before we fit the front, we need to put the screws back in here. And we're going to start with this one, which holds the display in place. Three screws at the top. I'm going to get these tabs inserted in the front. There we go. Now we're going to look at one of the few areas of electronics in these machines that can give you a little bit of trouble, which is the power supply area. And two most likely failure positions are some of the capacitors. They're much better than some manufacturers, these capacitors actually. They're not bad, but it's worth going over those and checking them. There's two power supply boards here. And the other area of failure can be the voltage regulator chip, so that's STK5216. If you've got power supply rails completely missing, then it's most likely that that chip has failed. They're not that hard to source, you can still get hold of those. So we're going to have a look at some of the capacitors. What is a bit of a nuisance is it's not that easy to work on, really kind of have to take the power supply out in order to get to a lot of these capacitors. So we are going to pop the power supply out. Of course, make sure that you're not plugged into the mains when you do this, or it might be the last thing you ever do. Now, it's a little while since I've done one, so allow me to remind myself. I think we'll start by unplugging the connectors, or at least some of them. Slightly annoyingly, one or two of the wires are actually soldered in, and the connector is at the other end, miles away down inside the machine. Okay, so that was 5 screws I had to undo in order to get that out. Now you have tolerable access. Okay, we have the power supply out here. Now, the capacitors that are most likely to cause problems, it's worth checking some of these and even these high voltage ones. But there's 2 here which are particularly prone to causing problems with the clock. Either that the display flickers or that it resets to 0 every time you switch the machine on. The ID numbers are 5204 and 5207, but sometimes I've found actually the component for at least one of those, 5207 I think, is not always actually installed there. It's installed somewhere else on the board, so you may have to go a bit of a search for it. Now we're going to put our ESR meter here on one of them. So we're going to look for capacitance and series resistance on 5204, which is 47 microfarads. I have remote control operation on this machine. 52 microfarads, 0 ESR, so that looks absolutely fine. And the other one here, which is at a funny angle on the board, you do wonder if you're looking in the right place at all. In circuit. So really the only way to test that one is to pop it off the board. If you have to replace either of these, just replace them both. Or if you're having any problems with the clock not functioning or flickering or the display just not being right, then just replace them both. So this is the 5207 one, and it's strange because it's at a funny angle. Out it comes. So that's 100 microfarad, 16 volt. Let's see what it meters out as. "95 microfarads. Not bad, but it's not unusual for that to fail. So because of the risk that heating it up has reformed it, I'm going to replace it anyway. After all, it's old enough. And the original one was 85 Celsius, but I think it would be better to replace it with 105. So I'm going to replace that with a 100 microfarad 25 volt rated at 105 Celsius, so that I don't get any problems with that in the future. Got to be a bit careful installing this particular one because it's going in at such a strange angle and it's under this heatsink. It's really awkward, and you mustn't get it to short out on the nearby Zener diode, so it's all a little bit fiddly. Okay, so we've changed one of those capacitors. Okay, I'm refitting this power supply now. Reattach those connectors. Probably didn't need to unplug them in the first place. So there's these 4 screws, the corners, plus one in there. Now, one of the capacitors down here is 2,200 microfarads. I've just been through them and tested them, they're all great. But if you get a lot of hum on the picture, that's to say black bands moving up and down the picture, that 2,200 microfarad capacitor there is quite a likely culprit for that. But you'd certainly want to check all the capacitors if you get hum bars on the picture. Now, one more thing I wanted to show you. The tape we were playing earlier, which was giving really awful results, was mouldy. So it's hardly surprising it was giving terrible results. But if you find tapes that really do seem to have a lot of white flashes on them, and you would hope that they would look cleaner, it could be that the dropout compensator could use a small adjustment. This seems to be something Sanyo set quite conservatively. I've found in the past that some Sanyo machines would benefit from a small adjustment of the dropout compensator. So The dropout compensator is abbreviated DOC, and on this can at the back you can see it says DOC there. So that's dropout compensator adjustment. There's a tiny little preset in there. If you're finding you're getting a lot of dropouts which don't seem to be handled properly, they're white streaks rather than what should happen is a dropout should be, the line above the dropout should be repeated, so you actually lose vertical resolution. If you think that it's not handling dropouts particularly well, a small adjustment to the dropout compensator can help, and I've found that the VTCM series machines, such as VTC5000, are particularly prone to that. And if there is an impression that Sanyo machines don't give such a good picture as Sony, I think it's largely because that control is set conservatively. If you set it up a little bit so that it compensates for dropouts slightly more, you might find a more pleasing picture from a Sanyo machine. There is something about Sanyo. The pictures are somehow a little less smooth than from Sony. It's hard to put your finger on exactly why. But still, sometimes I've had the odd tape that just plain won't play on a Sony and will play on a Sanyo. So they can be good machines. They can do a grand job. Okay, we've finished this particular VTC5150. I'm happy that it's in very good working order. I'll play some tapes on it in a moment and test it some more. But we've been right through that, and I'd be happy to use that machine myself. I'm just going to demonstrate the dropout compensator is working well on this machine. Let's play a bit of this horrible mouldy tape. And you can see that there are occasional interference effects due to the poor quality tape. But the dropout compensator is disabled during picture search. So watch how much worse it is during picture search, immediately after it. Just as I'm coming out of picture search, you see a lot of white flashes and trails on that picture. See them? Just for the moment as it comes out now. And then, much better. So what's happening there is a dropout compensator is disabled now, and then it enables. And you see how much better it gets. Dropout, 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 good. Right? Dropout, 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 good. That shows us that the dropout compensator is working well on this machine. If you got those white flashes all the time, then that would imply the dropout compensator needs adjustment. It's working well on this machine, no need to adjust that. So what do we have here then? Another Sanyo VTC5150. This one, we have some more issues. Strangely, firstly, and this is, I've never seen anything like this before, somebody's drilled a hole in it. I can't imagine why somebody would drill a hole in the front of a video recorder. So there's a bit of a mystery. I don't know if someone's trying to access something behind that. What else do we have? Well, let's power it up. Well, it's running, but there's no clock. Nothing. No hint of it. Okay. We'll put a tape in. This is the mouldy one again. No picture. Not even a hint of a picture. So, what's going on? Well, two scenarios I can think of. One is that there's a power supply fault which has taken out both the clock and some of the electronics, which is resulting in no picture. Or we have two separate problems, that the clock's not working and there's no picture either due to an electronic fault or possibly just contaminated heads. So this one's going to be a little bit harder to sort out. Let's see what we can find. Perhaps we should start with the power supply. Switch it off. I've already taken the 3 screws out the back again. Let's have a look at the power supply capacitors first, see where that gets us. Oh, and remembering what I said earlier, let's switch off a monitor. So this is 5204, which I think is 47 microfarads. Let's see what we get. That's terrible. You can see that. It reads 37 microfarads over 20 ohms ESR. And the other one you can't really read in circuit anyway, so that's the 100 microfarad one. So we'll take those out and see where we get to. Okay, I've changed those 2 capacitors, checked a few of the others, and they seem to be okay. So let's see if that's helped at all with the clock function. If not, then I think I would probably suspect the regulator IC. But I would probably try to find the diagrams and go through and check the power supply readings, but I haven't actually, at the moment, got the diagrams for the 5150, only for the 5000. Right, let's see what happens then. Throw those capacitors away. Everything's still plugged in. Haven't done the screws up though. Do we get a clock? Here's the great switch on. No clock, so we have bigger problems. Okay, I'll tell you what I've done in the last few minutes. I've been right the way through all the connectors on the power supply, comparing the voltages to those given on the VTC5000 service manual. They seem to be exactly the same as far as the power supply is concerned, and the power supply is fine. So why there is no clock and no picture, we don't know. I've cleaned the heads. There's a certain knack to this, actually, cleaning heads on these. I love my little mini microscope thing, and I've got no chance of showing you the way I do this, unfortunately, because it's so hard to do. But with a little microscope like this, I get it so you can see the head tips right on there, obviously not hitting it, and you should be able to get it so that you can see the head tip glisten, because it's a kind of black shiny composite sort of graphite material. You should be able to get it to shine, and when you can see the whole thing glistening without any bits of oxide stuck to it, you've got it clean, using proper head cleaner sticks as I showed you earlier. So I checked that the heads were clean, so that is not the reason for no picture. Anyway, in picture search it overrides some of the picture mute thing, so you really should get something, even if it's noise, and I'm getting nothing. So there's a fault. An electronic fault, it would seem. I suppose I'm coming to the end of the road on this then, because we've got a picture fault, or picture failing. We've got a clock fault, less important, but there as well. The power supply is good, so we don't know why this machine's not working. And I'm probably going to leave it there. But I wanted to show you something in terms of debugging. So I'll just power this machine up. You can easily fool the machine into thinking you have a cassette in there. You put your finger on here and it does that little shuffle. You can even let go of that pin, and now it thinks there's a tape in there. So if I select fast forward, it will fast forward, and it actually only checks that this take-up spool is rotating. So provided the take-up spool is rotating, which of course it is in fast forward, the machine runs quite happily with no tape in there. For rewind to work, you'll have to spin that, otherwise it'll think, oh, that's not working, there's a fault. But if you do that, you can exercise the deck, and you can exercise it in play as well, and of course the take-up spool's going, And you can get a feel for how much take-up torque there is. If there's a problem with the take-up torque, you can put your finger on there and get a feel for that. So it's a good way to exercise the deck. And that's all working fine. Now I want to show you a bug. This applies to the VTC5000. This is a 5150. It applies to this. I have a feeling they fixed it on some of the later VTC5150s. First, a bit of history. The model before the 5000 was, strangely, 5300, 5400. And they were always laced machines of the earlier type. Now, I believe that they copied some of the code from the Syscon, the system computer, into this machine and made a mistake. So when the machine gets into a fault condition and it can't drive the reels, the 5300, 5400 would go into its stop position, which is laced, stop. You don't want that in these models because these do all their tape transport in unlaced. But I think they left the code in there to lace it. So watch what happens when you hit rewind and the spool is not being turned. It goes into lace and stops. Now, considering you've just proven that the spool is not rotating properly, right, and therefore it can't get the tape back into the cassette, right, the last thing you need the machine to do is lace up. Because when you unlace, if this spool can't rotate, as it will because there's no fault here, but if that spool can't rotate, you're going to finish up with tape spilling out all over the deck, and it's going to get involved under the loading ring and get all chewed up. Now, when I hit stop, it will successfully run this spool to pull the tape back into the cassette. But if your machine's not working, for example, because this belt snapped, you are now in a right mess because you hit rewind, it didn't rewind, this spool wasn't working, it detected that fault, it goes into the lace-up position, pulls loads of tape out of the cassette, you press stop, and it can't suck it back into the cassette. Chew up. So that was a bug on some of these Sanyo machines. Now, I've been working this with the cassette carriage in. Actually, you can even go as far as taking the cassette carriage completely out. And so what you then need to do is fool two parts of the mechanism. One to say there's a cassette in, which is this, and the other is the cassette carriage down, which is this thing here. So you'd need to simultaneously, when you've got this cassette carriage out, simultaneously pull that forward and push this down, and you can make the machine, in fact I just did then. Right, okay, so I've got the situation where the cassette carriage is up or could be completely removed, and still the machine thinks there's a cassette in there. So that's a great way to do debugging. If you've got a problem here with the reel drive, you've got some kind of problem with reel tables or something to do with the reel drive or lacing, you can exercise the whole machine now with no cassette in there, which is really handy. Right, that is the last of what we're going to be doing on this machine. We're not going to cover earlier models such as the VTC5300, VTC5400 or the very old VTC9300 here. They have much more complicated mechanisms, there are a lot more parts to wear out, many of which are hard to obtain now. So unless you're some sort of video recorder repair enthusiast, you're not likely to want to tackle those older models. However, much of what we have done today does cover international variants such as these NTSC and CCAM models. Sanyo were a huge force in consumer electronics in the 1980s, but alas, the company barely exists anymore. It was swallowed up by Panasonic and to a lesser extent Funai, Kyocera and Whirlpool. Such a shame when you consider how well built these video recorders were. Let's remember their advertising slogan.
C. Sanyo. Vendor side.
Well, if you stuck it to the end of this video, well done. It's been a long one, but we've covered a lot of ground. I hope it's been useful, so please do like, share and especially subscribe, then I will do more content on audio and video technology. Bye for now.